5.2 Systems of Equations, Solve by Substitution. There are three methods that we will see in Chapter 5. The first method was to solve by graphing, which we saw in 5.1, and then we have substitution in 5.2, and in section 5.3 we have solutions by addition. So in this case, we want to review and or learn how to solve by substitution. So basically what we want to do is we're going to look at three examples. Here's the first example. We have two linear equations and we want to solve for x and y. The idea for substitution is to solve for one of these variables. So essentially you pick one of the equations and we solve for x or for y. It doesn't matter which equation you choose or which variable you solve for, you will get the same exact answer in either case. The trick here is, if possible, to solve for the single variable. That's the easiest one to solve for. So for this example, the single variable is y. If I look at the x here, it has a 7 multiplied to it, or we have 5 multiplied with the x, or 2 multiplied with the y. The only single variable is this one right here. So this is the easiest one to solve for. So we will take the second equation and solve for y. I'm just going to rewrite the equation. Make sure you write out your steps clearly so everything's clear as to how you solved. So in order to solve for y, there's a few things we can do. We can add y. We can add y to both sides. Which gives me 7x plus y is equal to 4. And then to isolate y, subtract 7x. So we have y equal to negative 7x plus 4. So now this is solved for y. Since I used equation 2, I need to substitute into equation 1. So let's start our substitution step. So we are going to substitute for y. We take negative 7x plus 4, substitute for y. Make sure that you use parentheses, it's very important. We have 5x plus 2, parentheses, negative 7x plus 4 equals negative 10. And of course, now distribute the 2. 5x minus 14x plus 8 is equal to negative 10. Combine like terms, which gives us a negative 9x plus 8 equal to negative 10. We subtract 8 from both sides. Negative 9x is equal to negative 18. You will divide by negative 9, which gives us x equal to positive 2. I found my x coordinate. Now we need to find the y coordinate. How do you find the y coordinate? Well, we take our answer and we substitute back into one of these two equations, doesn't matter which one. You can also substitute into the equation that we solved for y, because this equation is essentially the same as the second equation. So this one I think is easier, so we will substitute 2 for x and solve for y. Y equals negative 7 times 2 plus 4. Y is negative 14 plus 4. Y comes out to be negative 10. You can box your answers separately. We can also write our answer as an ordered pair. 2 comma negative 10. Make sure that this is in the correct order. X first, Y second. Now, you can always check that your answer is correct. Let me show you how to check your answer for this problem. In order to check, what we're going to do is we will substitute 2 and negative 10 into both equations. We have to check both equations. So we check that the solution works for both. Start with the first equation. 5 times 2 plus 2 times negative 10, and that's supposed to give us a negative 10. Since I'm checking, I will have a question mark right there. Let's calculate the left side. We have 10 minus 20, and we can easily tell that we get negative 10 equals negative 10. The solution works for the first equation. Let's check the second equation. 7 times 2, is that equal to 4 minus a minus 10? 7 times 2 is 14. 4 minus a minus 10 is really 4 plus 10, and we get 14 equals 14. The second equation works as well. Since both of them work, I can clearly say that my solution of 2 negative 10 is correct. Let's look at the second example. Okay, this second example contains decimals in the first equation. If you see decimals, what we need to do is multiply here by 10. 10 because we just need to move the decimal one place to the right. So multiply through every single part by 10. All right, so if we do that, let me just write this out. So we're multiplying by 10, which again moves the decimal one place to the right, which will give us the following. 1x minus 2y equal to 14, and the second equation is the same. We are still solving by substitution, in which case we need to determine which variable to solve for. And so I noticed that we have y as a single variable and we have x as a single variable. You can choose either one to solve for. I'm going to solve the second equation for y. So I will just recopy my equation here and solve for y. Subtract 3x both sides, which gives us y is equal to negative 3x plus 14. Since I solved the second equation for y, we need to substitute negative 3x plus 14 into equation 1. And of course, we will use the equation without decimals. So let's go ahead and do that. And by the way, 1x and x are exactly the same thing. So let's start. We have x minus 2. Don't forget, you need parentheses. Negative 3x plus 14 is equal to 14. Distribute. X plus 6x minus 28 is equal to 14. Next, combine like terms. 7x minus 28 is equal to 14. We need to now add 28 to both sides, which gives us 7x is equal to 42. Divide by 7. X is equal to 6. We need to now find y. So how do you find y? You can take 6, substitute it into the first equation, the second equation, or the equation that we solved for y. The equation right here is the easiest. Let's use that. We have y equals to -3 times 6 plus 14. Y is equal to -18 plus 14, which leaves us with a -4. Again, you can box your two answers separately, or your ordered pair solution would be 6, -4. And you can follow the same steps to make sure that your answer works. You can check by substituting back into your two equations, and then you'll see that the solution does indeed work. One more example. Okay, for example C, this is a problem that contains fractions. So if we have fractions, we can eliminate the fractions by multiplying by the least common denominator, LCD. So we will multiply both of these equations by the corresponding LCD. If we look at equation 1, the LCD is 20. Multiply everything by 20. And if you look at the second equation, the LCD comes out to be 20, or actually we can use 10. The LCD comes out to be 10. You can use 20 here, but 10 is a smaller number, so let's use 10. Okay, so what we do is we multiply 20 with every single term, so it's 20 times x over 5, 20 times y over 4, 20 times -3, 20 times 0. Same idea with the 10. So let's start. So for our first equation, we end up with 4x plus 5y minus 60 is equal to 0. Equation 2 becomes x minus 5y plus 10 is equal to 0. So these two equations are slightly different because the constants, the numbers, happen to be on the left side. You can leave them here or you can move them to the right side. It doesn't matter. Now we need to solve by substitution. The single variable is x. So let's solve the second equation for x. It's the easiest way to go. I will rewrite my second equation. What we need to do is subtract 10 and also add 5 to the other side. We get x is equal to 5y minus 10. So this is solved for x. Since I used the second equation, then I need to go and substitute 5y minus 10 into the first equation. So let's do that. 4 parentheses 5y minus 10 plus 5y minus 60 is equal to 0. We need to distribute the 4. We have 20y minus 40 plus 5y minus 60 is equal to 0. Combine like terms. 25y minus 100 is equal to 0. You need to add 100 to both sides. $25y is equal to 100. Divide both sides by 25. We get y is equal to 4. So that's done. We need to find x. So for x, we can use the equation right here, the one that's solved for x, which is x is equal to 5 times 4 minus 10. Simplify, 20 minus 10, and so our answer for x comes out to be 10. So we have our solution. If you want to write your ordered pair, it would be 10, 4. So essentially the point that you get here, if you remember, is where the two lines, when graphed, intersect. If you were to graph the two lines here, they would intersect at 10, 4. And the same idea works for the previous two examples.